Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss about efficiencies of hydraulic turbines. So before going to discuss the efficiencies of hydraulic turbines, I'll just give a brief idea about the turbines, how this turbine is to work and what are the processes are involved in this. Okay. So previously also I have discussed, again I'll just remind you, this is the turbine part is there. This is one of the turbine, actually this is called Pelton turbine. Just I have taken the snapshot of that. And actually here we have a dam will be there. And from this dam, the water used to comes out through a penstock or through a long pipe, and the water will be flows through this one, and it is going to strike here. The nozzle part is there, so that the high velocity of water will be come out from the pipe, and this velocity of water is going to strike over a veins or used to called as a blades, or even we can call it as a bucket also. And these vanes or buckets are fixed on a runner. This is the runner part, and the runner is fixed on the, it is mounted on the shaft. This is shaft. Okay. And the shaft is connected, this shaft actually it will be connected to a, here generator will be there. Okay. So here generator is there, so the shaft is connected to the generator. Now if you see the process in the dam, the water which is present here, so that there we have potential energy will be there. That means there some height is there, so this is potential energy. And when the water is flowing from the dam through this pipe, through this penstock to this turbine, so it's going to strike this one as a kinetic energy. Okay. And due to the strike of water jets to the blades started rotating. The blade is fixed on the runner, so runner started rotating. Runner is fixed on the shaft, so shaft also started rotating. Now this rotation gives a mechanical energy. This rotation gives a mechanical energy of the in the turbine. And as this shaft is connected to this generator, so from this generator the electrical energy is going to generate. That means here the electricity is going to produce. That means you can see here potential energy of water was present. Here it is water. So now we have converted this water to electrical energy through these other processes. Okay. So this is about the turbine usefulness I told you. Now we'll see what are the efficiencies of hydraulic turbines and why it is required. Now the thing is hydraulic, the name itself it's given hydraulic. Basically it indicates about the water. Okay. And the second one is efficiencies. Efficiency is actually, this states the performance or what kind of quality it is having and how efficient it is. So the efficiency used to denote by eta, and it used to calculate by output. What is the output from the equipments or machinery things, and what was the input was supplied, what we have achieved as output and what input we have supplied to this machine. So based on that, efficiency will be calculated, so that we can say some performance of some kind of equipments are there. Okay. Now these efficiencies are categorized into four types for here. Basically, first one is hydraulic efficiency. First one is hydraulic efficiency. Second one is mechanical efficiency. Second one is mechanical efficiency. And third one is volumetric efficiency. Volumetric efficiency. And last one is the overall efficiency. Overall efficiency. So all these four things we are going to discuss here. Now first one, the hydraulic efficiency. This is denoted by eta H. And this one mechanical efficiency, eta small m. Volumetric efficiency, eta V, and this is eta O. These are the denotions are there for all this efficiency. Now the first one we'll see about the hydraulic efficiency. So the formula is hydraulic efficiency, actually it is the ratio between the power given by the water to the runner, or we can say the power delivered to the runner of a turbine, or we can say power delivered to runner of a turbine to the power supplied at the inlet. Okay, because we know that runner, if you see this runner is nothing but this is a rotating. This is a rotating part of a turbine. As this total things actually we can say indicates a turbine actually. Okay. Now, how to calculate the efficiency, hydraulic efficiency? So that means what were the power supplied at the inlet and what are the power delivered to the runner. That means we can say the ratio of power given by the water to the runner, because water is flowing through this one, okay, and the runner is nothing but this one, okay. So power delivered to runner and of a turbine, because it is fixed in the turbine, that's why we can say it is the ratio of the power given by water to the runner of a turbine to the power supplied by the water at inlet condition of the turbine. Here we can write of turbine. Here also we can write of turbine. Turbine part was not written here. So for more clarification, we can write this. Now we can see this is the power delivered to runner of a turbine. So this one also we can write this is runner power. Finally, what is the output from here? That means this runner, how it is rotating, and what is the power at this runner. So power delivered to runner, that is runner power, and what is the power supplied at the inlet condition at this point, at this position. So that is what is supplied here. This is nothing but water is supplied here. So we can write this is water power. Okay. So the hydraulic efficiency can be written runner power by water power. Now again, if you want to again write about the runner power and what is water power, that also can be written. So runner power, that means power delivered to runner, that is runner power. So runner power actually, the runner power can be it can be written for two different things are there, because these turbines are going to be categorized in many types are there actually, like impulse turbine, reaction turbine. There will get some different values for different turbines. Okay, for Pelton turbine it will be different, and for reaction turbine it will be different. So runner power will be some different values for different turbines will be there. Okay, finally, and water power I'll tell you. So water power actually, this is nothing but we can say the power supplied at inlet, condition. Okay, inlet of the turbine, or this is also called water power. So this one we can write, okay, W is nothing but weight of water, which is striking the vanes, of the turbine per second. That is weight of water into what is the head, what is the net head of the turbine. Net head we have seen in the last lecture. What is the distance from here to here, and after some losses, how much distance is that? That is net head. W into H divided by, we can write this is 1000 to convert into kilowatt. Now as I told you, weight W equal to what I told, that weight of water which is striking the vanes of the turbine per second. So this one again we can write W equal to, we know that mg, again m plus we can write m plus, I can write rho v into g, again with respect to per second, with per time. So per time means we can write this is second, again volume per second I can write this is, this one you can say volume per second, that is discharge. So rho into q into g. So if I put the value of this one here, so finally what we are going to get, so water power equal to what I can write here, rho gq, rho, here it is g into q on place of w, into h divided by 1000. So this much kilowatt. This is water power, correct? And this is the equation for water power. We can give equation 1. And here, if the liquid is considered as water, then we can put the value of, this is general equation. This is the fluid is general equation. You can consider any kind of liquid except water. If water is there, then we can put the value of rho density equal to, this is 1000. So 1000 will be cancelled. So what we can write, this is water power equal to, this is we can write rho no, there will be no rho here, only G Q H. So here we can write this is G Q H, this much kilowatt. Okay, this is equation 2. This is for water, and this is for other fluids. This is for other fluid. Okay, and now as I told you, runner power is nothing but like the power delivered to the runner, and that will be different for different turbines. Like Pelton turbine, value will be different, and for radial flow turbine the value will be different. So anyway, so this is the efficiency of hydraulic valve. Okay, now the next one is we'll discuss about the mechanical efficiency. I hope you understand this one. Now the next one is mechanical efficiency. Now see, mechanical efficiency, where I told you, when it started rotating, when the runner started rotating, then it's create the mechanical energy actually. But here for efficiency calculation, we is to how will you define? So the power delivered by the water of the runner, the power delivered where? By water, obviously by water to the runner of the turbine. Anyway, though everywhere water is supplying, but at what level? The power at the shaft of the turbine. Power at the shaft of the turbine. That means the power delivered by water to the runner of the turbine. That means that will be transmitted to the shaft. That will be transmitted to the shaft of the turbine, obviously. So once it is striking here, this due to the rotation, okay, the runner is shifting to this shaft. Finally, it's coming to the shaft. Okay, that's why the power at shaft of the turbine, this is output. Okay, final output. Okay, see how much we are applying here and how much is going to rotate, because in see, when we have supplied some power here, obviously there are some losses will be there. Okay, so here the losses is considered the mechanical loss. So that due to the mechanical loss, the power available at the shaft of the turbine will be less than the power delivered to the runner of the turbine. That means how much power we have delivered to this runner, okay, that much power will be not transmitted to the shaft. That means, okay, that's why the power at shaft of the turbine with respect to the, so you can say it is the ratio of power at the shaft of the turbine divided by power delivered by water to the runner. So always keep in mind that, as I told you, efficiency equal to output by input. So our efficiency, to calculate the efficiency, your output will be always less than input. Okay, because see, input we may give 100%, but the same 100% we won't get as output. Okay, slight less percentage will be there, less value will be there, so that our efficiency will get maximum 100%. We can get very rare chance. Okay, so our efficiency is to always less than 100%. Okay, so here how much power was delivered to this runner? Okay, see, water is striking here. After striking, it is shifting to the runner here. So from this runner to this shaft, okay, some losses will be there. That is called mechanical loss. Okay, so due to this mechanical loss, we can say the ratio of power available at the shaft, to the power delivered by water to the runner is called mechanical efficiency. And this one we can write simply, this is our shaft power divided by, what is this here? Runner power. This is runner power. Okay, shaft power by runner power. Here turbine is given, this is shaft, final is shaft, so shaft power, and this is runner power. So here also we have seen, this is runner power, and this is power supplied at inlet. Inlet is nothing but, here what is given? Water. We can write power supplied by the water at the inlet of the turbine. That also you can write. So that is water power. So this is about the mechanical efficiency. Okay, I hope you understand. Here one more term I'll write, mechanical loss. Okay, here I'll write, this is mechanical losses. Due to these losses, same amount will be not transmitted. Now the next one is volumetric efficiency. Okay, the volumetric efficiency is nothing but the volume of water striking the runner. The volume of water, okay, striking the runner of a turbine is slightly less than the volume of water, okay, which is actually striking the runner, or you can say less than the volume of water supplied at the turbine. Because see, volume of water supplied to the turbine is nothing but, see, from this, how much volume of water is coming out from here, okay, and what is the volume of water is coming from here, okay. Some of the water maybe is come out from here, discharged to the tail race, and how much is going to strike here, that is, okay, there is some difference will be there. So the volume of water striking the runner of a turbine, so volume of water which is striking the runner of a turbine, obviously this will be less, this will be less, and this will be more. A simple, if you talk in the simple manner, this is less and this is more. So volume of water supplied to the turbine, because few amount of water, few volume of water, we can say, is discharged to the tail race. Now here tail race will be there, so here in this tail race, few volume of water will be discharged to the tail race. Even without striking this one, few amount of water, few volume of water will be fall down here. So how much volume of water came, that much amount of volume, that much volume of water is not strike to this runner, okay. That's why it is called as the volume of water actually striking the runner to the volume of water supplied to the runner. So here also we can write, this one we can write, this is, okay, yeah, and this is volume, here no need to write anything shaft power or runner power, because only this is about, this talks about the volume, the quantity, okay, of water which is supplied and how much actually it is striking to this one, okay. Now we'll see the next one, that is overall efficiency. So overall efficiency is very much important. So finally, if you see, yeah, this one, this is the second one, and this is our third one, and this is our fourth one, okay. So fourth one is this one, overall efficiency. So overall efficiency, actually it is the ratio of, like, power available at the shaft, okay, power available at the shaft of the turbine to the power supplied by the water. So power supplied by the water, obviously supplied at the water inlet. So power supplied here, one more thing you can write, power supplied by the water here. So supposed to write here, by written here, power supplied by the water at the inlet of the turbine, okay. And you can say actually the volume of water, volume available at the shaft of the water, actually. So that is nothing but, see, this is actually the shaft, this is actually the volume available at the shaft of the turbine, in the sense this is nothing but the shaft power, okay. And here we can say one more terminology, it is the ratio of power available at the shaft of the turbine, here volume, you can say this is power, okay, this is, can say, power available at the shaft of the turbine, not volume, okay. So power available at the shaft of the turbine, this is shaft, means where is the final output, because shaft is connected to this generator and their electricity will be produced. So, and initially what is, this is final one, this is final, and initially what, power supplied by the water at the inlet of the turbine. So this is also, so finally what we got here, the overall efficiency equal to, if you see, now came shaft power, final came shaft power, okay. And initially what, initially it is given water power, where you have seen initial condition, power supplied by at inlet condition, power supplied at inlet of the turbine by the water. So here we can write, this is water power, okay. And this terminology we can split, and we can write in other ways, like, yeah, this is, okay, let me write in this way, like shaft power divided by water power into, just I'll multiply one runner power and I'll divide one more runner power here. Now if you see, if we again, this one we can write, this is overall efficiency equal to, I can write in this way, shaft power divided by one runner power, right here, runner power, into, I can write this is runner power divided by water power. Now we can see shaft power by runner power, where we got this one. This is mechanical efficiency. So we can write this is mechanical efficiency into runner power by water power. Initially we have seen that is hydraulic efficiency. So this is our final statement. We can say, so overall efficiency equal to mechanical efficiency into hydraulic efficiency. So the final statement we can give in this way: overall efficiency equal to mechanical efficiency into hydraulic efficiency. Okay. I hope you understand this theory. It is simple, but we need to remember one by one, like from where it's starting and from where it is ending. See, all these terminologies are interlinked with each other. If you see the hydraulic efficiency, so hydraulic efficiency is this talks about the water, obviously. So after supplying the water here at the inlet condition, how much power delivered to the runner? Because initially we are striking to this vane, and this vane is supplying to the power to the runner. So at this condition 1 and this 2 condition. And next coming about the mechanical efficiency. So mechanical efficiency also, how much power was actually supplied to this runner, and from this runner to shaft, how much it was transmitted. Okay. So initial supply made, obviously it will be more. As I told you, your input will be always more. Okay. This will be always more and this will be less. So here also same thing, mechanical losses, there will be some difference will be there. And next is volumetric. Volumetric efficiency, nothing but how much water was supplied exactly, it is striking to the runner, and how much actually supplied to this one. So here there is some gap will be there. So due to this, there is some loss of water, and that will be come to the tail race. This is our tail race. So how much is coming exactly, that was not striking to this blade. Also some losses will be there. So which is more, that will be in the denominator, keep in mind. And next one is the final on the overall efficiency, that is nothing but the power available at the shaft of the turbine to the power supplied by the water at the inlet of the turbine. I hope you understand this efficiency of turbine. If still if you are having doubt in this, you can give a comment on the comment box. Thank you.